Hi, and welcome to the screencast on Earth's Surface, Chapter 2.1, Minerals Are All Around Us. Before we start, make sure you turn to a clean page, the next clean page in your notebook, and set it up in Cornell fashion. Remember that you have space on the left for questions, and about 5 lines from the bottom, draw another line where you have space to write a summary of your notes when you're finished. Here's the heading of your chapter, 2.1, Minerals Have 4 Characteristics. Make sure you write that on the very top line, and that you also write today's date. Alright, minerals have 4 characteristics. First of all, minerals are all around us in everyday life. We use them in our cell phones, computers, the pots and pans that we cook our food with. The food itself has minerals in it, and the vitamins. The water that we drink has minerals in it. The jewelry that you wear, the watches that we use to keep time with, the makeup you put on. The pencil that you're using to write with right now is made of graphite. Even ice is considered a mineral. So we use minerals every single day. But in order for a substance to be a mineral, it has to have all 4 of these characteristics. The first one is that it forms in nature. It cannot be made by man. So this is not something that we can make in a factory. It's made in nature. Make sure when you write your notes that you emphasize each one of the characteristics. So I have them in red. You can highlight them, put them in capitals, underline them, all of those things. Make sure that you make them stand out so they're easy to see. Alright, so if it's formed in nature, here are some examples. You don't have to write the total explanation, but maybe just write example and then the ones that I have listed in red. So halite. Halite is actually salt, and halite forms when ocean water, warm ocean water, evaporates, and what's left behind is the salt. Another example, talc. There are 2 big pieces of chunks of talc in the back of that picture there, and they actually form deep in the earth under high pressure and temperature, and we use talc for talcum powder, baby powder, for makeup, all kinds of things. And then a third example, now this is actually a rock. A rock and a mineral are not the same, and we'll talk about that another day. But within this particular rock, granite, it has lots of different minerals in it that form when molten rock cools. And I've pointed out some of the different types of minerals within this particular piece of granite. So the first characteristic is that it forms in nature. The second characteristic is that it is a solid. Everything is in one of 3 states of matter. It's either a solid, a liquid, or a gas. For example, water, which is H2O, when it's in its solids form, it's ice. And ice is considered a mineral because it has all 4 of the characteristics that we're going to talk about today. Liquid water and water vapor, even though they still have the same chemical composition, H2O, are not considered a mineral because they're not solids. So far we've talked about that it has to be made in nature and it has to be a solid. The next characteristic is that it has to have a definite chemical makeup. A mineral consists of a specific combination of what are called elements. Everything on Earth is made up of one or more of these elements. This is called the periodic table of elements, and it shows everything that anything can be made of on Earth. They actually are finding new ones every once in a while. So this is actually, I think, an old copy of the periodic table. And there is also a copy of this table in your Pride Planner. Next year you're going to be learning all about the periodic table. But anyway, minerals have one or more of these elements as part of its chemical makeup. Most minerals contain more than one of these elements. There are some elements like copper, which is on the right, gold, silver, elements like these have only one element. However, most elements that we come into contact, most minerals that we come into contact with have more than one element, like the mineral salt. That is a combination of sodium chloride, NaCl. So the NaCl is the chemical makeup of salt. Cu, copper, is the chemical makeup of copper. The fourth characteristic that a mineral has to have is that it has a crystal structure. A crystal is a solid in which the atoms are arranged in an orderly, repeating 3D pattern. Make sure that you emphasize the word crystal because that is a vocabulary word. So here's an example of what is and it is not a crystal. So quartz is a crystal, mineral, that is made from silicon and two atoms of oxygen. Glass is made of the same two elements. However, quartz is considered a mineral because it has a repeating 3D pattern. You see how it has a distinct pattern to it. However, glass, when you look at the one on the right, there's different sizes, there are different shapes. It's not in any pattern at all, and it's not certainly repeating. It doesn't have a pattern like the one on the left. So it has to have a crystal structure where the arrangement is orderly, repeating, and 3D. Now, every mineral has its own unique crystal structure. Two minerals, like graphite and diamonds, can have the same chemical composition, which they're both carbon, but they will have different crystal structures. So in other words, you may have the same chemical makeup. Two minerals can have the same chemical makeup, but they will end up having different crystal structures, which makes them two very different looking minerals. And so girls, which would you rather have? The mineral on the left or the mineral on the right? So the mineral on the left is obviously graphite, and the mineral on the right is diamonds. And if you look at the crystal structure, the one on the left is graphite. It has a very distinct crystal structure versus the one on the right, which is a diamond. So they're made of the same thing, but because they have different structures, they look very different. Now, normally when crystals grow, they're growing within Earth's crust, and so there's a very limited amount of room for the crystals to grow. So as you can see in the picture, they're all kind of on top of each other. They're pretty small. But however, sometimes in nature, there is enough space for them to grow all by themselves. And when that happens and you have a crystal that's formed like the one on the right, they're called perfect crystals. But again, perfect crystals in nature are rare because they need open space to grow. There are 6 crystal groups, and I would like you to write down the names of each of the groups. You do not have to draw the picture that comes up above them, however. So the 6 crystal groups are cubic, tetragonal, hexagonal. Now hexagonal also may have grouped with it a group called trigonal, which is sometimes referred to as the 7th crystal group, but most of the time they're kind of grouped together because they're very, very similar. But hexagonal is the more common group that you'll see. So cubic, tetragonal, hexagonal, orthorhombic, monoclinic, and triclinic. Now, geologists look at these and decide if a mineral has these crystal shapes by looking at not only the shape that they have, but the number of faces that are similar or sides that are similar, and what their internal angles look like. So here's an example. They give a little bit more explanation if you're interested as to what differentiates one crystal from another. These are some examples of gems that belong to that crystal group. So diamonds are considered cubic, zircon is tetragonal, emeralds are hexagonal, amethyst, ruby, sapphire, those are all considered trigonal, which again is part of the hexagonal. Topaz, you may recognize as part of the orthorhombic. Azurite, which we can find here in Arizona, is considered monoclinic, and turquoise is triclinic. And those are just some examples. You can always go to gemologyonline.com to go and look at some other examples. When conditions are just right in Earth's crust, look at the amazing crystals that can form. These are in Naica Crystal Caves, Chihuahua, Mexico. And look right here, this is a person. Look how giant these crystals are. Here's a person here, and obviously here's the person here. Okay, these crystals are absolutely amazing and were discovered by accident about 12 years ago. We're going to be doing a follow-up activity looking at these crystal caves so you can get to learn the story behind it. Alright, that's it for our minerals and what their 4 characteristics are. What are the 4 characteristics? Say them to yourself. Okay, hopefully you said that they form in nature, they have to be a solid, they have a definite chemical makeup, and they have a crystal structure. That's it for today.